Okay, some radical and exponent. We're going to just do the intro and some key pieces to know. So make sure that you know all your radical numbers. So square root of 1, square root of 4, square root of 9, square root of 16, 25 is the next one, 36, 49, 64, 81, 100, 121, and 144. Okay, those are some things that you probably want to have pretty memorized in the back of your head. Okay, so now if I do something like this, what is the square root of 36x to the 4th? So now what's the square root of 36? 6. And square root of x to the 4th is x squared. It's x squared times x squared is x to the 4th. The square root of 0.0016. So I'm just thinking about the square root of 16, which is 4. Okay? And then I have 4 decimals. So therefore, my answer will have 2 decimals. So 2 decimal places. Okay? The square root of the square root of 250,000. So the square root of 25 is 5. And then I'm counting 4 zeros. So my answer will be 5 with 2 zeros. Okay. The square root of 9 over 100. So it's all in there. So if I do that, I think about the square root of 9, which is 3, and the square root of 100, which is 10. And last example, the square root of negative 81. That actually has no solution, because you can't square root a negative number. Because to get, like, square root of 81, right? 9 times 9 is 81, right? You cannot times the same number by itself to get you a negative number, because 1 would have to be negative and 1 would have to be positive, which is not squaring, because that's 2 different things. So that doesn't work. Okay, so in grade 9, you probably would have seen these exponents. X to the 7th times x to the 10th. So when you times, you add the exponents. So 3x to the 5th times 7x to the 4th times the coefficients, so 21, and add the exponents. Okay, division. So if I have 20x to the 6th divided by 4x squared, divide the coefficients, 5, and now you subtract the exponent numbers. If I had 7 to the 11 over 7 to the 5th, the base is 7, and the exponent is 6. I subtract the exponent number. And the power rule, so x to the 7th and then to the 10th. Now I multiply the exponent number, 2x to the 4th, and then I'm going to cube it. Well, here, this is where lots of people forget, 2 also needs to get cubed. So that's 8. And then the rule with the exponent would be to multiply it. Okay, don't ever forget the exponent rule on 0. If any number is to the 0 exponent, it would be 1. And exponent 1, if you had an exponent of 1, it would just be the same base. Okay, evaluate these expressions. So 5 to the 12th divided by 5 to the 10th. So evaluate means come up with the exact number. So this would simplify by subtracting the exponents, and then it comes out to 25. 4 to the 0 plus 8 to the 1. So anything to the 0 is 1. If the exponent is 1, then you just have your base. So that results in 9. Okay, what's the difference between those two expressions? Well, this one is telling me to do BEDMAS, to do this, then times by -1. Okay, so this is telling me -1 times 4 squared. So 16 and then negative. Versus this is telling me to do -4 times -4. It's all of that squared. So this is positive 16. So big difference in how those are written and how they come out. You might think it's not that big of a deal, that they look pretty much the same, but they're not the same thing. This BEDMAS tells you to do an exponent and then multiply. This is taking -4 as the base that gets squared, but this is having a base of 4, and then later you would times it by -1.